Hi. Today we're going to look at Chapter 3, Section 2, and the first true learning objective, which is to identify the temperature units scientists commonly use and we will learn how to convert between them. So what are the units that scientists commonly use? That would be degrees Celsius and Kelvin. And in this class, when we are doing labs and we make temperature measurements, we'll take temperature measurements in degrees Celsius. Those are what our thermometers are, and that's the standard temperature unit that everyone uses pretty much besides the United States. So everywhere around the world, if you listen to the weather report in the morning, you're going to hear that today it's going to be 23 degrees Celsius out. The problem with degrees Celsius is that it is not an absolute measurement. What an absolute measurement is a measurement where 0 means none. And that just makes sense. Like, well, obviously, if I run for 0 seconds, that means I have not run at all. If something has 0 mass, it can't be matter, right? Because even a proton and an electron have some sort of mass. If something is 0 meters long, it isn't even made of protons or neutrons or electrons. It's not really matter. But if something has a temperature of 0 degrees Celsius, does that mean that there's no energy? Because remember, temperature and energy are related. Temperature, energy, and actually movement of the particles are all related to each other. So if something has 0 degrees Celsius, does that mean that the particles aren't moving at all and that there's no energy? Actually, no, right? Can you have less than 0 degrees Celsius? Sure, a cold day outside can be less than 0 degrees Celsius. So scientists needed to figure out what was that lowest temperature possible. And how they did that was they took a series of measurements of different gases. So you can see on this picture here, the red and the blue and the green are just 3 different gases, and they took readings of their temperature and how it affected their volume. And as you have seen in the past, I'm sure, as you cool down a gas, the particles move less. They are able to, they exert less pressure on whatever container they're in, and their volume will become smaller. So if you take a series of measurements and then extrapolate that data, they found that no matter what the gas that they used, they all reached, theoretically, what would be 0 volume at the same temperature. And that's how scientists determined what absolute 0 was. So absolute 0 is defined as the coldest theoretically possible temperature. It is 0 Kelvin. Notice that there's no degree there. It's not 0 degrees Kelvin, it's just 0 Kelvin. Degree is how we designate that a unit is not an absolute unit. This is where the movement associated with heat stops. And if you look at the divisions between, let's say, 0 degrees Celsius and 100 degrees Celsius, and the corresponding temperatures in Kelvin, we made it so that the difference between one division in degrees Celsius is the same as one division in Kelvin. So there's not what that actually means is that the conversion between those two is really simple. All you're going to need to do is add or subtract this number, 273.15, right? Notice 0 degrees Celsius, the freezing point of water. What is that in Kelvin? 273.15. 100 degrees Celsius, what is that in Kelvin? 373.15. So in order to go from degrees Celsius to Kelvin, we're always going to add, and you can say either 273 or 273.15. It really has to do with like what type of instrument you're using. If a question is asking me to convert from degrees Celsius to Kelvin and it says 25 degrees Celsius, since that doesn't have any decimal places, I'm probably going to use 273. But if another problem says 343.25 degrees Celsius, I may use 273.15. And then when we go to Kelvin, when we have Kelvin, and we go to degrees Celsius, that's going to be, of course, the opposite. You're going to subtract You're going to subtract 273 or 273.15. So there's a couple ways that I use to remember the differences between these two. I always remember that Kelvin is always larger. Okay, so if I'm comparing a Celsius and Kelvin, Kelvin is always going to be larger. And the other thing is that there's no negative Kelvin. That can help me if I get a little turned around with, do I add here or do I subtract here? Okay, so now let's do two practice problems with this, right? We're using our circle the do, underline the clue. So the first time we read the question, the element silver melts at 960 degrees Celsius. What is this temperature in Kelvin? So circle the do, the question is asking me, find its temperature in Kelvin. Underline the clue, that's 960. So I take 960. What do I do to go from degrees Celsius to Kelvin? Remember, Kelvin's always larger. So I add 273. The answer I'm going to get is 1233 Kelvin. So a few things. Remember that when we're doing addition, we don't need to worry about significant figures, but we need to worry about decimal places, which is why it doesn't matter if I use 273 or 273.15. If I had taken 960 and added 273.15, I would have wound up with 1233.15, but because this number has 0 decimal places, this number has 2 decimal places, my answer should have 0 decimal places, which would mean I just get rid of those last two. That's why it doesn't matter. And then I double check. Is my degrees Celsius less than Kelvin? Yeah, my Kelvin is always larger. Let's try the next one. The next one says liquid nitrogen boils at 77 Kelvin. That's my clue. What is the temperature in degrees Celsius? So I take my 77. I now subtract 273. And I wind up with negative 196 degrees Celsius. Is that okay for me to have a negative degrees Celsius? Sure. It's a negative Kelvin that we can't have. And again, is my Kelvin greater than the degrees Celsius? Yeah, positive 77 is a much greater number than negative 196 degrees Celsius.